Hi scholars, in this video I'm going to show you how to answer number 15 and 16. Starting with number 15, it says a 14 kilogram car experiences a force of 950 newtons forward when it begins moving and a frictional force of 210 newtons. Part A, what is the net force on the car? So one way to find net force is to use the equation net force equals mass times acceleration. This is an equation that we refer to as Newton's second law. Another way to find net force is to take the forces that are acting on an object and add them together. Net force means total force. And this second method is what we're going to use to answer this question. It says that there is a 950 Newton force on the car forward, and then against that force, because it's friction, is 210 newtons of force. And that's going in the opposite direction. So net force would require us to combine these two forces, and the way we're going to do that is with subtraction. So here, one way we can show these steps is to show that the force, we're going to call it an applied force, that 950 minus the friction force. So the net force equals 950 minus 210, and that ends up being 740 newtons. So the net force on the car is 740 newtons. For part B, the acceleration of the car can be found with net force divided by mass. This is also Newton's second law. Another way to find acceleration is using change in velocity over time. The one that's going to work out for this part is Newton's second law equation. Acceleration is the net force divided by the mass. Since we found the net force in the previous part, we plug that in for the net force, and the mass of the car is 1,400 kilograms. And I'm going to let you figure out what the answer to that is. The units would be meters per second, but in the Google form, don't put units, just put the number. All right, next I'll show you how to answer number 16. This is very similar to a question that you saw on the quiz. A bucket of water has a mass of 4 kilograms and is being pulled up by a rope. So that's got to be a tension force. The weight of the bucket is the force of gravity on the bucket, which is this equation. So this is what you have to use anytime it's asking for weight. We assume it's on Earth, so we use 10 for the number g, or 9.8. So the weight of the bucket is the 4 times 10, and that's 40 newtons. In part B, it says the tension force is 58. So you have to recognize that there's this tension force upward, and it's going against gravity downward. If the tension force is 58 newtons, force of gravity is 40 newtons, we were trying to find the net force, which is the total force. We're going to subtract those two. So it'll be tension force minus force of gravity, which is going to be 18 newtons. And then finally, for the bucket's acceleration, again, we could do it two ways. We can use change in velocity over time, or use net force over mass. In this problem, we're not given any information about velocity, so we have to use this rule. The net force is 18 from the previous part. The mass of the bucket is 4, and so that's going to get you the answer. And I'll let you figure that out with the calculator.